Welcome to IMS Gate Academy. I hope everyone is doing a preparation of the Gate 24 examination with full energy. Okay. So guys, first of all, tell me, I'm audible? Is the audio and video everything is fine? Is the audio, video, everything is fine? Just please let me know everyone first. Okay. Just let me know everything is fine. Okay, I think everything is fine. Great. So guys, in this today's session we'll be discussing theory of machine, and as all of you know that for mechanical engineering, theory of machine is one of the most important subject, and if you see the weightage is around 9 to 10 marks, right? And always every year a quality questions are coming, so we have to be very strong in the fundamental part. We have to be very strong in the concepts, right? Hi, good morning, Thiru. Okay, everyone. So the point here in this session that we are going to discuss is the quality problems that will boost your confidence. Okay. Already you have done the PYQ, right? PYQ you've done, and formula sheet, as every time in the classes I have told you to create the formula sheets, right? So because formula sheets will help you in the quick revisions. So in today's session guys, we'll be discussing some quality problems and we will be discussing the concept as well, so that it will give you an extra edge in your preparation part. Okay, now please take out your copy and pen here and we'll be solving the questions. Okay, next there is important information for you guys. Just you can join our Telegram group, IMS Gate Academy Telegram group, where you will be getting all the latest notification regarding the jobs and examinations, as well as webinars information will be given, and you will get daily quizzes, okay, which will help you in your technical exam preparations, right? So the link is already given in the description of this particular video, and with that link you can join this Telegram group. Okay. Okay, here I want to again inform you regarding our live program of IMS Gate Academy, right? And as you can see, 800 plus hours of content we are giving. Apart from that, theory books, exercise books, and AMTS online mock test series we are also providing. Okay, and one of the main important feature of our live program is one-to-one mentorship. This is a completely one-to-one mentorship. You and your concerned faculty who has taught you the subject, he will be addressing all of your doubts. Okay, every faculty will try his level best to give all the possible solutions of your doubts. So you will never feel that you are in this preparation journey, you are alone. The whole IMS Gate Academy is always with you in your entire gate preparation journey. So this mentorship sessions are very, very important feature of our live program IMS Gate Academy. And finally, the test series I already told you. This test series will make you prepare for the technical examinations, right? So if you have any query regarding the live program, you can just call on these numbers, and if you want to book a free counseling session, you can also book the free counseling sessions as well, right? Now we'll be starting our theory of machine topic, and the first topic that I'm going to discuss here is the simple mechanism. Okay, I hope everyone knows, like in simple mechanism, lot of questions has been asked in the previous year, like topic related to angular velocity ratio theorem, quick return ratio, okay, single slider crank mechanism, double slider crank mechanism, degree of freedom, Grashoff's law. These are the topic from which you will get the questions in the gate examination. So we will directly first look into the problem, and then we will discuss the concept as well. Okay, so first I will give you some time for this particular problem, and then after that we will discuss the entire concept here. So question is for the crank slotted lever quick return motion mechanism. This is one of the most important topic for your gate examination. Now see what information they have given in the question. Distance between the fixed center is 200 mm and the length of the driving crank is 100 mm. Determine the inclination of the slotted bar with the vertical in the extreme position and the ratio of cutting stroke to return stroke. So you need to understand what they are actually asking. Okay, they are asking the inclination of the slotted bar with the vertical in the extreme position. Now, what is extreme position? So in your mind, there should be one picture of crank slotted quick return motion mechanism. Okay, at what instant? Extreme position. For extreme position, you should have some image in your mind. Then only you will be able to solve this question. Yes or no? That is what very basic thing, everyone. So just try this one and tell me your answer. First of all, for the inclination and then the ratio, cutting stroke to return stroke. Okay, that is what you need to tell me. So 2 minutes for this particular question. Then after that, we will be discussing this concept with the some small video, okay, of this crank slotted quick return motion mechanism. That video will help you to visualize this particular mechanism, and you will never forget the image. Okay, you will easily remember that image in your mind always with that particular video. But before that, please everyone calculate. Hi, good morning, GATE aspirant. Okay. Inclination of the slotted bar with the vertical. Once you will draw the extreme position diagram, you will get to know which angle they are asking. Okay, so first point is you need to draw the extreme position diagram. Everyone, please try this one and tell me your answers. Everyone, try this particular problem. As I told you, the first step in this particular problem is to draw the extreme position diagram. Without extreme position diagram, you cannot solve this particular problem. Yes or no? That is what very basic thing. So please everyone try and tell me your answers. Beta alpha, see, we will not associate beta alpha because that is what a sign convention or basically our notation. So it depends person to person. We will understand the mechanism. Once you have understood the mechanism, then there is no need to remember what is alpha, what is beta. Okay. Generally in the textbook, if you see, they will mention alpha, beta. Alpha is what cutting stroke angle, beta is what return stroke angle. So we will not remember like that way. We will remember the mechanism, how the mechanism works. We will understand its extreme position and then we will solve it. So there is no need to remember what is quick return ratio, alpha divided by beta, what is alpha, what is beta, that is not required. Mechanism we have to visualize. Okay. So I am expecting everyone tell me the answer, because see, distance between the fixed centers is what? There is a crank center and there is a one point about which your slotted bar is what oscillating. There is a point of crank center, then there is another point about which your slotted bar is oscillating. So distance between the fixed center is given as 200 mm and driving crank length is 100 mm they have given. GATE aspirant QWM. Tell me the answer. Inclination. Angle you have to tell me. What is the angle here? Okay. $60. You got 60 degree? Okay. See, the main thing is at least you're trying. Once you try, you will understand the concept here. Okay. Without attempting the question on with yourself, like you're not solving the question and directly if you see the solution, then there will be no learning. Once you already know the some basic concepts, at least try. Okay, you need to attempt the question. Once you attempt, then only you will understand its basic point where you have done the mistake. Otherwise, if you just see direct solution, you will not get the learning. Now see, before discussing this question, I want to show you the animation, how it actually works. See, just try to focus on here, everyone. I want everyone to focus here. See how the mechanism works. This is very, very important, right? There is a crank which is under complete rotation, correct? There is a slotted bar which is what oscillating like this. Okay, there is a center of a crank here. Okay, I will play the video for you. So this is a center of a crank. This is a point about which what happens, this slotted bar is what oscillating. And remember this point, this attachment and this blue color tool is not a part of our mechanism. Quick with machine question. See, yes, obviously it is a quick return motion mechanism, correct? So the point here, you need to understand how many links we have here. Okay, for the mechanism, this is a fixed link, one is a slotted bar, and this is what a slider, and this is a complete crank. Once you have understood how actually mechanism works, then it is very easy for you to understand, okay, any problem related to crank slotted quick return motion mechanism. Right, now see, this is a general diagram that we will be having for what? Crank slotted quick return motion mechanism. Okay, now see, this is our fixed center. One by one, all the link I will explain here. Please try to focus, everyone. This is our fixed link. Okay, this is the slotted bar extreme position. This is another extreme position of slotted bar. This is what a crank for this extreme position, and this is another crank for this extreme position, right? This is a crank for this slotted bar position, and this is a crank for this slotted bar position. So for two different positions, I have drawn the diagram. Next, this is a circle, because the crank is under complete rotation, so obviously a circle will be formed. Next, this is what a general slotted bar. This is a general position. Previously, if you see, this is first extreme position, this is another extreme position, right? And this is any general position. So there is first extreme position, there is another extreme position. This is what you need to understand. Like again, if you want to understand from the video here, okay, so please focus here. So see, one extreme position, another extreme position. So from here to here it is moving. So this is one of the extreme position, this is one of the other extreme positions. Is that clear? I hope from the video it is very easy to understand the whole mechanism, how actually works. Now, coming back to the question here, determine the inclination of the slotted bar with the vertical in the extreme position. So here the first step is draw the extreme position diagram. Okay, we have to draw the extreme position diagram. So how we will draw it? Simply first there is a circle we have to draw, because as the crank is under complete rotation, so we have to draw one circle here. This is our fixed link, the point about which slotted bar will be oscillating, and this is what the crank. Now, slotted bar extreme positions I will show with a different color here, like this. So this is one of the extreme position, this is one of other extreme positions. Is that clear? Now, this is the crank for this position, and obviously it will have 90 degree, and here also it will have this 90 degree. Now, one thing you need to understand here, okay, From this extreme position to this extreme position, the angle turned by the crank is known as cutting angle, which is generally we will represent with alpha. So it is not mandatory like we have to mention alpha also always. No, it's not like that. It's your choice basically. From this extreme position to this extreme position, cutting happens and this cutting tool moves towards right. And again it will return back, and for that angle involved here is beta, let's suppose. So I am mentioning here beta by 2 here and beta by 2 here. So total angle will be beta. Clear? Beta by 2, beta by 2. Is it clear everyone? Okay. Now actually what they are asking, inclination of the slotted bar. This is what slotted bar extreme position with the vertical. Vertical means this fixed length basically. So the actual thing that they are asking here is this angle theta. This theta they are asking. That is the question here. Theta value they are asking. Now once we have drawn this diagram, extreme position diagram, after that only trigonometry we need to know. Only trigonometry is what required here. Once you have drawn this diagram, then only trigonometry is required. Now why I am saying that? Because this is theta. Which trigonometry function I need to use here? In front of angle always perpendicular will be there, and this is what the hypotenuse, because this is what base. So perpendicular divided by hypotenuse will be what? Sin theta. So I will use a relation here, sin theta equals to, perpendicular is our crank. Crank length is 100 divided by 200, which is sin theta value is half. So theta value obviously 30 degree. 30 degree. So this is the answer here. 30 degree is the answer here. Is it clear everyone? So how we have solved it? First we have drawn the extreme position diagram. Second, we have identified this is one of the extreme position, this is one of the extreme. They are asking inclination of slotted bar under extreme position with respect to vertical. So this theta they are asking. Now the ratio of cutting to, okay, they are asking the ratio of cutting to return stroke, that is quick return ratio they are asking, which is angle during cutting divided by angle during return. Theta you already find out, this is theta. Clear? Okay, no issue. Cos nikal diye. Okay, no issue. Point is, if you have understood this extreme position diagram, then it's fine. Later is what basic mathematics, calculation mistakes you should not be doing. So with practice, you will try to basically reduce. If you do more practice, this basic mistakes will gradually reduce. But for that, you need to keep practicing more and more questions. Okay. So theta we have found out, and this is 90 degree. So this angle will be obviously 60 degree. Okay, because total angle will be 180 degree. So beta by 2 value. So let me write it here itself. And one more thing, alpha plus beta equals to 360 degree. This is also you should remember. So theta is 30 degree. I can mention beta by 2 as 60 degree. So beta value will be 120 degree. Alpha plus beta is 360. So beta alpha value will be 240 degree. And finally, quick return ratio answer you will be getting as 2. Okay. So quick return ratio answer you will be getting as 2. This is what your answer is. So this is answer number 2 and this is answer number 1. I hope this is clear. Right? Done. Now one more question from this crank slotted quick return motion mechanism, and that question nowhere asked till now in GATE paper. Till now in the GATE examination history, never they have asked such type of problem. So that is very important. I am telling you guys, that question from crank slotted lever mechanism is very, very important. So this one is basic. Okay, done. And also this particular video also helps us to correctly visualize the mechanism. If you are able to visualize and if you remember the whole thing here, then it will be very easy for you to understand the whole mechanism and solve any question related to crank slotted quick return motion mechanism. Got it? Okay. Now next, this question, guys, this is very important. Okay, this one is very important, so everyone please give it a try for this particular problem here. And this is, I'm telling you, one of the most important question, and you can expect such question in your GATE examination. You can expect this question in your GATE examination. This is very important question. Okay, so whatever you have understood till now, please apply whatever all understanding you are having regarding this topic. Please apply here and try to solve it. Right? Do it fast, everyone. Again, quick return motion mechanism they have told here. Crank and slotted lever type they have already mentioned, because two types of mechanisms we are having, Whitworth and crank slotted, right? The ratio of maximum velocity during return and forward motion is 2. This information is very important. They have mentioned the maximum velocities. Maximum velocity during return and maximum velocity, okay, during forward motion. This ratio is 2 they have given. This ratio, this information is very important. This ratio is very important. Okay, the length of the slotted lever they are asking. The length of the slotted lever, 500 you got, no, 500 is not correct answer here. Maximum velocity during return divided by maximum velocity during the forward motion. Okay, so it is not quick return motion mechanism. First of all, understand this thing. This is not a quick return motion mechanism. Here only maximum people will do mistake. This is not a quick return motion mechanism. What is quick return motion mechanism? The time taken during cutting divided by time during return, which is proportional to the angle turned during cutting divided by angle turned during return motion. This is the ratio of maximum velocity during return divided by maximum velocity during the forward motion. This information is not a quick return motion mechanism. So please don't be confused here. Right? Offset, no, this is not an offset problem. Offset cranks, quick return motion mechanism problems are different. This is not an offset problem. Actually, there is a relation, there is a formula here, the ratio of maximum velocity during return divided by maximum velocity during forward motion. There is a formula here. And what is the formula? Okay, let me write it here itself. That formula I will write separately, and please note it down in your formula sheet as well. This formula you need to note it down in your formula sheets. Okay, C plus R divided by C minus R. Now what is C and what is R? C is a center distance, okay, or it is a distance between the fixed centers. Two centers we are having now. One center is the crank center, another center is the point about which slotted bar is oscillating. That distance we are talking about. Or you can also consider this as a distance of, or basically the length of connecting rod. Because in your crank slotted quick return motion mechanism, which link is fixed? Which link is fixed? Your connecting rod is fixed. In case of Whitworth quick return motion mechanism, your crank is fixed. Okay. So C is the distance between the fixed centers. So let me write it here. Distance between fixed centers. R is crank radius. R is crank radius. This is what the formula here. This is one of the most important formula, guys. Till now, this formula, the question related with this formula, they have not asked till now. In engineering services examinations, they have asked already this type of relation based question. They have asked there in engineering services, but not engineering services conventional also, not in objective, right? So this is very important relation. So with this relation, you can get the answer of length of slotted lever also. So please everyone try this particular problem. I've simply mentioned the direct formula here. Use this relation, because C plus R divided by C minus R equals to 2. This ratio they have given. Okay, use this relation everyone. See, this is our extreme position diagram of your crank slotted quick rate and motion mechanism, right? Okay, let me mention all the details here. Let's suppose this is O, this is A. Oh, this length is what fixed here. So what they have given, this distance OA. Okay, this OA distance is what C we usually call it. Let's suppose this is B. So this AB is known as R, crank radius. Correct. That is what I've mentioned. C. OA distance is what C. Why? Because this is the distance between the fixed center. Center about which crank is rotating. This is the center about which your slotted bar is oscillating. Clear till this point? Okay. Now what ratio they have given? C plus R divided by C minus R is 2. So if I use this relation here, C plus R equals to 2C minus 2R. So you will be getting C equals to 3R. This is the relation we will be getting. Yes or no? Very basic thing. C equals to 3R. Okay, now what we are going to do with this information? This is what very important here. They have asked what thing? They are simply asked, first part is slotted lever length, and they have also given the length of the stroke 250. So this is the total distance is 250. Okay, this total distance is 250. So let me just mention this information. Now next, what is the next step? See, everyone knows this angle will be beta by 2. This angle will be 90 degree. Now if I use cos beta by 2, okay, cos function I am using, base upon hypotenuse, in front of angle, this is what perpendicular, this is what base divided by hypotenuse. Base is what R and hypotenuse is what C. Ratio of R by C, ratio of R by C is 1 by 3. So cos beta by 2 is actually 1 by 3. So from here you will get the answer of beta by 2. Simply use cos inverse of 1 by 3. Tell me the angle, everyone, fast. Tell me the angle of cos inverse 1 by 3. What will be the beta by 2 value? Okay, tell me the beta by 2 value, and then we'll be calculating. Okay, as alpha plus beta is 360 degree, So we'll be able to calculate alpha as well, and after that we will calculate quick return ratio, that is angle of cutting divided by angle for the return motion. Do the calculation everyone first. What is beta by 2 angle? Cos beta by 2 equals to 1 by 3. So what will be the answer of beta by 2 angle? 78.36. Okay, everyone calculate. Cos inverse. Remember, we have to do what? Cos inverse of 1 by 3. It is 70.528. 70.528 degree. So don't do some basic calculation mistakes, because see, every concept you have understood, everything you know, but in the final step if you do small calculation mistake, then whole of the effort that you have given in that numerical will go waste. So that should not happen. Okay, so be careful regarding the calculations, everyone. Right? So 70.528, then accordingly we will calculate alpha, and finally quick return ratio also we can calculate. So everyone please mention your answers for alpha answer, then please mention your answer of quick return ratio also. Okay, that calculation you can do very easily. So quick return ratio we have found out, simple thing. Now second, actually the first part that they are asking, the length of slotted bar. Again we have to use trigonometry here. We have to use the trigonometry, because total stroke length is 250. Okay. See, if I just extend this center connecting rod, this angle will be 90 degree. Let's suppose this angle is theta. Assuming this angle is theta. Calculation mistakes se. So see, we have to be very calm. Okay, understand this point. If we are in very much hurry, like we want to do the question as early as possible, and so in that situation what we'll do, we'll do fast. We try to do the solution as fast as possible, but here actually we'll do some small mistake that we don't understand also. Okay, where we have done this mistakes. So be calm, take your time and try to solve the question. First priority should be what? Answer should be right. Okay, so don't solve the question so fast that eventually you will going to do some calculation mistake. That should not happen. Okay. So now what I am telling here, in order to calculate length of slotted bar, let's suppose slotted bar name we have mentioned OC. So question is how to find out this OC. Again we have to use trigonometry here. We have to find out the length of OC, length of slotted bar here. Okay. Now see everyone, carefully understand OC. So this OC is there. So understand this triangle OC. Let's suppose this is D. In triangle OCD. In triangle OCD, in front of angle perpendicular. Okay, this distance will be half of 250. 125. Half of 250 will be 125. So 125, this length is given, perpendicular divided by hypotenuse. So sin theta if I use, perpendicular is 125 divided by hypotenuse, that is what OC, which we need to calculate. But what is sin theta? What is sin theta? This is beta by 2, this is 90 degree. So this angle will be what? Okay, 90 minus beta by 2. 90 minus beta by 2. So 125 by OC. From here you will get the answer of OC distance. So do the calculation now. Do the calculations and tell me the answer of OC as well finally. Because this theta can be written as 90 minus beta by 2. Then only the summation of all the angles of a triangle will become 180 degree. So theta equals to 90 minus beta by 2. That's what I've used here. Got it? Do the calculation and tell me the answer, everyone. Tell me your answer. Now it's very easy to solve this question. And please mark this question as one of the most important question for your upcoming GATE 24 examination. Right? So GATE aspirant, tell me your answer. See, you don't need to put beta by 2 value. See, actually, two kind of students will be there. What they will do, beta by 2, they will say, okay sir, beta by 2 we have already calculated, sin 90 minus 70.528. Then they will minus 90 minus 70 minus 90 minus 70.528. That subtraction they will do, and then they will calculate the sine of that value. Then they will use 125 divided by OC. Then they will calculate OC. But try to understand, sin 90 minus theta becomes cos theta. Yes or no? Sin 90 minus theta is cos theta. Cos theta basically here cos beta by 2. Sin 90 minus beta by 2 is cos beta by 2. So cos beta by 2 value 1 by 3. 1 by 3 equals to 125 divided by OC. OC becomes 125 multiplied by 3. See, sometimes we will make simple calculation so much tough. See, why some people are solving the question like in a very less time and some are taking more time. This is the reason actually. I'm telling you this thing frankly. Sin 90 minus beta by 2 immediately you will put it here, and then cos beta by 2 they will calculate, okay, and then they will solve it. Simply we know that cos beta by 2 value is 1 by 3. Why there is need to put that angle in cos function? Are you getting my point? Cos of beta by 2, why you will calculate when you know the answer 1 by 3? This is required to calculate alpha and ratio of alpha and beta. Answer will be what? 125 by multiplied by 3, 375 mm is the answer. 375 will be the correct answer. Yes or no? 375 is the correct answer here. So I hope you have understood this problem clearly. And if there is any doubt, so please ask. 375. Yes, GATE aspirant, your answer is absolutely correct. 375. Right? So you need to understand this relation is very, very important. So please note it down in your formula sheet as well. For GATE 24 examination, this is one of the most important thing that you can expect. So I'm telling you, nobody knows, like, if in the GATE booster session that we are taking, some of the question similar to that are coming in the GATE examination. No one knows. So please attend all the GATE booster sessions of all the subjects, okay, because it will give you an extra edge in your preparation part. It will basically boost your confidence, because once you solved quality problems, you will understand multiple things from single question. See, from single questions we are understanding multiple things, right? Already PYQ done, then that's great, but after that some quality problems are required. So that's what we are discussing in GATE booster sessions. फॉरवर्ड बैकवर्ड कर सकता है, फॉरवर्ड बैकवर्ड कर सकता है. I think you are talking about the ratio. See, this ratio simply what? Ratio of maximum velocity during return divided by the forward. So C plus R divided by C minus R. Right? Clear? Okay. Now see, next thing. This question. Again, very simple question if you know the relation. Yes, that's what the simple modification in the problems they will do. See, every year similar kind of questions are coming, but different context will be there, different question framing will be there. They will frame the question in a different way, okay, but the concept will remain same, na? Now this problem, again, this question is very easy if you remember the relation, direct relation to calculate the length of the cutting stroke or simply stroke length. There is a direct formula for the stroke length calculation. So if you remember that relation, then it is very easy. Otherwise you need to derive it in the examination, and I am telling you, deriving a relation in the examination all will makes you little bit confused also, and it will be difficult also at that time to derive one relation, and obviously it will take more time now. So better remember such relations from which you can easily solve the questions. Okay, so that's why again and again maximum times I've repeated, formula sheets, you have to write all the formulas, because it will help you to do quick revision. And one more thing you can do, like you have created formula sheets, say you have done multiple revisions. Now do one thing, take A4 sheet, blank A4 sheet paper, and try to write all the formulas whatever you have remembered till now, and then you will check how much formulas or relations you are able to write. See how much you are able to write. Let's suppose 100 formulas you have written in your formula sheets. Out of 100, how many formulas you are writing without saying anything? So that's how you need to check how much preparation you have done. See, we are doing preparation, but we have to regularly check at regular interval of time. We have to check our preparation, whether we are going in the right direction or not. So take a blank A4 sheet, write down all the formulas in one go, and see how much you are able to write. Okay, you got the answer 500. Okay, we'll see whether it is correct or not. So formula of the stroke length is twice multiplied by, okay, this. I hope you know what is. First of all, let me tell you the stroke length here. Let me tell you the stroke length basically. Stroke length is the movement of this tool from one of the position to another of the position, like left extreme to the right extreme. That is what the stroke length. From left extreme to right extreme, whatever distance it has travelled, it is known as the stroke length. Right? Now see. In the last problem also, in the question they have given the stroke length as 250 mm. So what I have drawn here, this is one of the extreme of slotted bar, another extreme of slotted bar. So that point you need to connect, and there is a line, that line shows what? Stroke length here. Clear everyone? Okay. So formula here, length of slotted bar okay, length of slotted bar multiplied by the crank radius divided by connecting rod length. Divided by connecting rod length. Now just put the values and tell me your answers. 500 you already got. Okay. Now let me just put all those values here. 2 multiplied by slotted bar length. Slotted bar length 500 they have mentioned. Multiplied by crank radius. Crank radius they have given as 100. Divided by connecting rod length. Connecting rod length, that is what the distance between the fixed center. Connecting rod length is the distance between fixed center, which is given as 200. Now this 2 becomes 2 divided by 200, it becomes 100, 100 cancel out. 500. Yes, absolutely. Your answer 500 is correct. Right. This is what correct answer is. Option C. Clear, everyone? Is this part clear? So stroke length is what? Twice multiplied by the slotted bar length multiplied by crank radius divided by connecting rod length. Slotted bar length we should mention here. Okay, again this formula very important, guys. So you need to remember this relations. Okay, otherwise deriving this formula or relation will take lot of time. Done? Okay, great. Now moving to the next problem. Okay, before moving to the next problem here, I want to just tell you regarding this Whitworth also. See how actually the Whitworth quick return motion mechanism works. This is again very important, because if you want to understand any mechanism, you need to know how actually it is moving, how the different links are moving with respect to each other. So just try to understand. Okay, here which particular link of single slider crank mechanism is fixed? Crank. So what happens? Your connecting rod becomes the driving crank here. Okay, see this is element, this link basically is what fixed, the black one. Yellow one is what? Our crank here, which is actually connecting rod but acting as a crank, driving crank. And this blue color is what? The slotted bar. And this is what? A slider which is sliding in the slotted bar. This is a hole, a slot is cut. This is what? A slot already cut there, right? This gray part and the red part you can for this moment you can remove. Okay, because this gray and red part are the attachments to our mechanism. Okay, that are the attachments. But 4 links or the 4 elements we are having: crank, connecting rod, slider and a slotted bar. So there is one basic difference. What is the basic difference here between crank slotted and this this Whitworth? What is the basic difference? Anyone can tell me? In crank slotted quick return motion mechanism, we have rotation to oscillation. Crank is under complete rotation, but slotted bar is what? Oscillating. But in this case, what happens? The crank, which is actually driving crank, under complete rotation, and as well as the slotted bar also is under complete rotation. Both rotation to rotation we are having. Please try to understand. Yellow part, focus on this yellow part. It is rotating, yes. Yellow part link is what? Our crank here, driving crank, which is under rotation about this point. Similarly, slotted bar is also rotating about this particular point. Focus here. About this point, slotted bar is also rotating. Correct. In this particular case, rotation to rotation motion happens. This is what you need to understand. But in case of crank slotted, rotation to oscillation. Here, rotation to rotation are happening. Is that clear? Now, like in previous case, like crank slotted one, we have understood the extreme position diagram. Here also we need to know the extreme position diagram. Now, let me tell you the extreme position diagrams here. See, extreme position diagram. See, try to understand extreme position diagram. So this is the cutting tool. Focus on this cutting tool. This is on the extreme left. Now, once it start moving towards right, that is what known as cutting stroke. It will reach to extreme right. Again, it will stop. Then again come back here. That will be known as the return stroke. Now, I will show you first here the cutting stroke here. Again, see, from here the cutting stroke start, and here actually it will stop. Okay, from here to here it has rotated, so cutting stroke. Now from here to here the return stroke will be there. Now see this, focus on this right tool, it will moving towards left. during return motion. So again cutting, this is the beginning of cutting, this is the beginning of cutting stroke. See, try to focus here. Okay, so basically cutting ends here. So see, from here the cutting will start and finally it will stop here. Cutting will stop here. Then after that return stroke will happen. Okay, finally again reach to its original position. This is what we need to understand from the mechanism here. I hope it is clear. Now, this is one of the extreme position and another extreme position is what? See. First extreme position, another extreme position. See, focus here. Yes, this is what your another extreme position. This is the end of cutting stroke. This is the end of cutting stroke. So one of the extreme position. And this is the beginning of cutting stroke, another extreme position. Now I have drawn separately both the diagrams here. See, one of the extreme position, that is beginning of the cutting. So let me write it here itself. Beginning of cutting stroke. Okay, here I will mention end of cutting or beginning of return stroke. And lot of time many students are having confusion, sir, which angle is cutting angle, which angle is return angle. Now I hope it is clear. So it is now very easy to identify which angle is cutting angle, which is return angle. So from here to here you will have a cutting angle alpha, and here to here return angle is there, beta, like this. Is that clear? Very basic things. So actually this mechanism video will help us to visualize the mechanism. That's why this is very important part here. So end of cutting stroke, beginning of cutting stroke, both the extreme positions diagram are clear. Now I will draw the extreme position diagram here itself. Again, see how what we need to draw. We don't need to draw separately. Single one diagram I will draw. Okay, see. Okay, this link is got fixed. So this is what we have, a crank. This is our crank. Now this is what our connecting rod. Because for Whitworth, connecting rod is behaving as a driving crank, or we can write it as acting as a driving crank. Acting as driving crank, right? So what informations they will give in the question? They will give connecting rod and the crank. Crank is fixed, that we need to understand in the Whitworth quick return motion mechanism. Your connecting rod is behaving as a crank. Okay, so they will give this information. Now about the angle. So as I told you, this angle, total angle will be beta, return angle, but this one will be half of that, that is beta by 2. So again I will use here basic trigonometry. So this is beta by 2, in front of angle this is what perpendicular, this become base, and this is what hypotenuse. So cos beta by 2 will be crank. Okay, crank radius divided by connecting rod. Connecting rod length. Okay, So this is crank radius, so better we will write it here as R. Clear? So again I am telling you, even if the Whitworth question comes, only extreme position diagram is what required to solve the Whitworth problem. So if you have understood this problem, then I don't think so you will face any difficulty in any of the Whitworth quick return motion mechanism problem. There is a question asked in few years back, like in 21 I think. There was a question asked from the Whitworth, and only single question asked till now from Whitworth. So I am telling you, go back again, solve that question. Only this diagram will help us to solve that question. It is very easy. Some of the data is what redundant in that question. Okay, we have to focus where? Crank radius and connecting rod. And this extreme position diagram we need to remember. This fixed link is crank, and this is what we are having is a connecting rod. And that two dimensions are only required. Once you have calculated beta by 2, okay, once you have calculated beta by 2 angle, then you can easily calculate alpha also using this relation, alpha plus beta 360 degree. Using this relation you will calculate alpha as well. And finally crank slotted mechanism, similar to that we can also calculate here in Whitworth the quick return ratio, QRR, quick return ratio also you can easily calculate here. Done? So everything is clear here. Now next question, and now this is an MSQ. Everyone please try this MSQ question. Okay, MSQs are like one of the most important questions nowadays, because many people are doing mistakes here. And what actually examiner will do in MSQ, they will involve multiple concepts in single question. In MSQs, multiple questions, multiple concepts will be involved, because option A will be related to some another concept, option B will be related to some another concept, like that. So you have to be like conceptually have a good command over the subject, then only you will be able to solve the MSQs, right? So give it a try here, everyone, give it a try and tell me your answer for this MSQ. MC question, yes, GATE aspirant, it is MSQ question. Tell me your answer. Okay, which of the following statements are actually correct here? I've mentioned here itself MSQ. Option C you are telling, in parallelogram mechanism all inversions are double crank. Okay, so tell me the complete answer. As it is MSQ, so multiple options will be correct, like A is correct, B is correct, all A, B, C, D are correct. So it depends. So please read all the options carefully and tell me which one of the options will be correct here. But for your information, C is one of the correct answer, AC. No, again not complete answer. Not complete answer here. Tell me the complete answer. C and D. All inversions are double rocker in a non-Grashof chain. Okay. Tell me the complete answer. Tell me the complete answer, because the partial markings are not there. In MSQ, let's suppose you have mentioned A as answer and A is correct out of other two options also. But you will not get the partial marking here, okay? You have to correctly mention which of the options are correct. If ABC are correct, so all ABC you need to mention. It's not like if you have mentioned AB, C you have not mentioned, then you will get answer marks. No, it's not like that. See, now smallest plus longest less than equals to P plus Q, then there will be at least one link which rotates 360 degree. Correct? Is that correct? Because they have mentioned there will be, okay, so chances is there that there will be at least one link which rotates 360 degree. Correct, this is there. Because if it follows the Grashoff's law, there will be one link which is rotating by 360 degree. Now, in Grashoff chain, double rocker mechanism is obtained when shorted link is made as coupler. Now, this is the statement where most of the student will do a mistake here. Now, if you please carefully read this statement, this option B. Okay, tell me, option B is correct or not? Forget about other option. First everyone tell me, option B is correct or not? Is it correct? Option B, yes or no? Option B is correct option here in this question. Tell me, yes or no? What do you think about option B? %100% not sure. Okay, I will tell you here. One basic thing I will tell. Grashoff's law, I think you know what is Grashoff's law. Simply that thing only I will tell you. Okay, but one important insight I will tell you here. Like, okay, any random, I've drawn actually parallelogram linkage, but any random 4-bar mechanism I will draw here. Okay, now let's suppose this is fixed. This link is basically fixed. Consider this as fixed. Okay, now I hope you remember there is an input link. This is what we have as output link, and the link which is connecting input and output is known as coupler. This much basics, I hope you know this thing. Coupler is that link which connects the input and output link. Input and output link. Now, if you see the option B, they have mentioned obtained when shortest link is made as coupler. Now, if this coupler is the smallest link, assume. Now, if it is shortest, link, then what will happen? Tell me. Type of mechanism. Which type of mechanism we will be getting? That is the question. Type of mechanism. If this is a smallest or the shortest link, opposite to shortest link is what? Fixed. Opposite to smallest is fixed. Which type of mechanism you will get? Tell me, which type of mechanism you will be getting? Right, because coupler only they have told is shortest link. Type of mechanism will be double rocker. Why double rocker? There are three cases. Try to understand. Whenever shortest fixed, double crank. Adjacent to shortest fixed, crank rocker. Opposite to shortest fixed, double rocker. Opposite to shortest fixed, double rocker mechanism. So actually, how we will remember the cases with respect to shortest? See, I will write down the cases here. How we will remember the cases? Try to understand. Shortest link is fixed, will be getting double crank. DC I am writing in short, double crank. Okay. Second, adjacent crank rocker. In short, I am writing crank rocker. And the third case, opposite to shortest is fixed. Double rocker mechanism. So actually this third case they have mentioned, but in a different way. So that's what I've told you. Concept will not change, but how they are framing the question, that we need to pick. Okay, that we need to actually understand. So they will be modifying the question. They will definitely change the question format. They will frame a new sentence there. They will frame a altogether completely new question they will create. But the concept will remain same. We know opposite to shortest is fixed, but they told coupler. So coupler here is shortest. So shortest, opposite, fixed. So this is a double rocker mechanism. I hope now it is clear, everyone. Is it clear? Done. So option B is also correct. So now you will be 100% sure. Previously you was not in 100% sure. Now you are 100% sure. Like option B is also correct. Second, next thing, option A already it is correct. You told. In parallelogram mechanism, all inversions are double crank. How it is possible? If I fix the smallest or the longest link. Okay, so it depends actually. So and if I see all inversions are double rocker in non-Grashof chain, yes, correct, absolutely it is correct. Clear, everyone? Done. So Grashof's law is very important for the GATE examination, I'm telling you, because multiple times lot of questions they have asked. Okay, so one more detail I will tell you regarding the parallelogram linkage also. Okay, so that you can understand easily. In parallelogram linkage, what happens? So this is the smallest links and this is the longest link. So same length link are placed opposite to each other. Same length link are placed opposite to each other. Correct? Okay. Now in this parallelogram linkage, in parallelogram linkage, if smallest or longest link fixed, you will always get a double crank mechanism. Double crank mechanism. So first of all, you need to understand what is a parallelogram linkage. Same link length are placed opposite to each other. Done. When same link length are placed opposite to each other, it becomes a parallelogram linkage, and in that, if any of the link, smallest or longest, are fixed, you will get double crank mechanism. So in parallelogram linkage mechanism, all inversions are double crank here. So this option. So see, options, which options are correct? Okay, we have identified. Okay, we have discussed all the options here. Clear? Done? Okay. Now, going back to the next problem. Next. Yes. From simple mechanism, I've told you initially, angular velocity ratio theorem is again a very important theorem here in the numericals. Because of that theorem only, we'll be like easily calculate the angular velocity of any link. And if you see previous year GATE questions, a lot of questions they have asked from this single angular velocity ratio theorem. So calculation of velocity, there are two methods involved. Either I can draw the velocity diagram, from that I can calculate, or I can use direct theorem, where we need to first identify the eye centers. That is first task. Location of eye center we need to know, then only I can use the angular velocity ratio theorem. Okay. So everyone, whichever method you want to use and tell me the answer here. First of all, this question. Then I will tell you where angular velocity ratio theorem is helpful and where relative velocity method is helpful. Okay, everyone. Do it and tell me your answers. Do it, everyone. You have 2 minutes for this particular problem. Okay, you should not be taking more than 2 minutes to solve such problems. So everyone, please quickly try to solve this question and tell me your answers. This is NET type problem. You need to mention your answer here. Okay, you got 20. Okay. First step is what? To identify the location of eye centers. Okay, let us first identify the location of eye centers. In order to find out the location of eye center, okay, what we need to do? Simply draw a circle here, and number of links are what? 4. So let me just give the name to the links. Okay, so fixed link is what? PR. So link 1, link 2, link 3, and this is link 4. So link 1, then there is link 2, link 3, and link 4. Now, how to identify the location of eye center? There is a small trick here that we need to understand. Okay. First of all, I will mention the I centers which we know directly here. Directly I will mention here. So link I12, link I14, okay, link 34 actually it is, and this is link we have I14. This is link I23. So I12, I23. This is 3 and 4, so I34, and this is 1 and 4 because this is fixed, right? Clear? Now other I centers that we need to find out here. How we will find out? See, I24. I need to find out the location of I24. Okay, now one of the basic thing that we need to know here is the Kennedy's theorem. Kennedy's theorem help us to identify the I center here. What is Kennedy's theorem? Whenever three links are in relative motion, all of their I centers will lie in a straight line. That concept we are using actually. Okay, now in order to go from 2 to 4, there are two ways, 1, 2 and 1, 4. I can go from 1, 2 and 1, 4. I can go okay, I12 and I14. So in order to go from 2 to 4, I12 and I14, this is one of the way or the possible path I can use. Another one is 2, 3 and 3, 4. Clear? Okay. Now 1, 2, 1, 4, there is one path and there is another path 2, 3 and 3, 4. Just draw one line. Just draw one line using 1, 2 and 1, 4. 1, 2 and 1, 4. So where is 1, 2? Here it is 1, 2. Where is 1, 4? Here. So one line we need to draw. Okay. 2, 3 and 3, 4. 2, 3 and 3, 4. Another line. So if I just draw the lines here, both the lines if I draw, both the lines are intersecting at this point only. So this is nothing but the location of I24 also. Okay. In a similar way, I need to find out location of I13. So in order to find out location of I13, what I will do? There is one possible way. In order to go from 1 to 3, one possible way is 1 to 2 and 2, 3. Another possible way is 1, 4 and 3, 4. Now again draw one line using 1, 2 and 2, 3. So 1, 2, 2, 3, one line I will draw. 1, 4 and 3, 4. 1, 4 and 3, 4, another line I will draw. So see where it will going to meet. 1, 4 and 3, 4. So this is 1, 4 and 3, 4. Horizontal line it will be there. And 1, 2, 2, 3, 1, 2, 2, 3, vertical line. So again here it will be meeting and that point will be I13. That's how we will identify the location of I centers. Is that clear everyone? Now which concept involved here in this identification of I center? Kennedy's theorem. Whenever three links under relative motion, the I centers will be on a straight line. For example, three links I have taken. One, okay, I will use different color here. Let me write it here. First, Kennedy's theorem again I will tell you. Link 1, link 2, and link 3. These are the three links under relative motion. So I centers, their I centers are I12, I23 and I13. All the I centers will be in a straight line. Now see, 1, 2, 2, 3 and 1, 3. 1, 3 and 1, 2 are in the same location. Okay. All these I centers will be in a straight line. Okay, will lie in a straight line. will lie in a straight line. Okay, according to Kennedy's theorem. Done? Okay, great. Now guys, try to understand. Once we have identified the all I centers, then it is very easy to use angular velocity ratio theorem. So let me write here for you angular velocity ratio theorem. Angular velocity ratio theorem we are going to use. Okay, now see everyone. Okay, so which link they are asking? First of all, they are asking the angular velocity of link PQ. So in our case, PQ we have mentioned PQ as link 2. Okay, link 2 we have mentioned here, and what they have given, PQ is for 40 they have given, QR they are asking, QR is 3. So omega 3 they are asking and omega 2 they have given. So let me write here for you omega 3 by omega 2 ratio. I can write omega 2 by omega 3, omega 3 by omega 4, or omega 2 by omega 4. Any two ratio I can write with the help of angular velocity ratio theorem. Is that clear everyone? Okay. So omega 3 by omega 2. Omega 3, that is what they are asking, QR. So QR I have mentioned as link number 3, and PQ they have given as 40, which is our link number 1. Now how I will write? It is this angular velocity ratio will be equals to the distance of the common eye center. What is the common eye center? 2, 3. Link 2, 3 common eye center will be I 2, 3. Now the distance of the link 2 with respect to fixed one is the eye center of fixed link with respect to, okay, eye center of link 2 with respect to fixed link is I12. Eye center of link 2 with respect to fixed link is I12, right? So what we need to do in numerator, the distance of common eye center from this I12. Now in denominator, I23 common eye center distance from the this numerator 1, 3, distance from the eye center of link number 3 with respect to fixed, that is I13. Now 2, 3 and 1, 2. If I see 2, 3, where is 2, 3 and where is 1, 2? Okay, here only. So 10 centimeter they have mentioned. Okay. Divided by 2, 3 and 1, 3. Where is 2, 3? 2, 3 is here, and where is 1, 3? Okay, 1, 3 is here itself. What is the distance? 10 only. Correct? Is it clear everyone? So that's what we need to put all the values here. Now tell me your answers finally. What answer you are getting? Okay. Distance of 2, 3 from 1, 2. Distance of 2, 3 from 1, 3. Again same distance, 10. So ratio become 1. So it means omega 3 equals to omega 2. And answer will be 40 radian per second only. Yes or no? Is that clear? Tell me everyone. So answer is 40 radian per second. So with the help of angular velocity ratio theorem, question become very easy. I'm telling you this point. The only challenge that you will face here is identification of eye center. And for that I have told you already, Kennedy's theorem we have to use. Kennedy's theorem we have to use in order to identify the location of eye centers. Done? Okay. Now I've told you na how to write all the ratios. I will tell here. Okay. Let me write it here itself. Then it will become very easy for you. So this is link number 1, link number 2, link number 3. This is link number 4. And let me write the eye center name as well, so that it become very easy. I12 and I13. This is I23. This is I34. This is I14. and this is I24 as well. Okay, that we have already discussed. 2 4 3 4, 2 4 3 4, and 1 3 and 1 2 both are same. The location actually same. Now, as I told you, if I have to write omega 2 by omega 3, what I will write? Common eye center first of all. Distance of common eye center from the eye center of a link which is present in the denominator with respect to fixed one. In the denominator is what? 3. So, eye center of link 3 with respect to fixed become I13. Again, distance of common eye center from that eye center which is present in the numerator with respect to fixed. Numerator is 2, link number 2 with respect to fixed I12. This is the ratio. Let's suppose I want to write omega 2 by omega 4. Common eye center is I24. Distance of common eye center from that eye center of that link which is present in the denominator with respect to fixed. So I14 divided by again I24 minus I12. Now let's suppose I want to write 3 and 4. Omega 3 by omega 4. Right. Now omega 3 by omega 4, common eye center is I34. Distance of common eye center from that eye center of a link which is in the denominator, that is 4 with respect to fixed, that is I14 divided by common eye center distance minus distance of a eye center which is present in the eye center of a link which is present in numerator, that is 3 with respect to fixed, so I13. So that's how you will be writing all the ratios. Now, no matter whatever question they have asked, whatever kind of mechanism they have given, you can easily solve the problem using this relation. Only one thing is required: identification of the eye center. Identification of eye center is what required. Okay, so once you have identified the locations with the help of Kennedy's theorem, then this ratio we need to apply, and then that's the question will become a matter of second for you. You can easily solve it. I hope it is clear, guys. Now moving to the next problem, this one. Now I've told you two methods we have. I told you two methods we have. Either we can draw the velocity diagrams, or I can do what? Use the angular velocity ratio theorem. Only one challenge we have faced in angular velocity ratio theorem is the identification of eye center. In relative velocity method, we will draw first all the velocity vectors. From that all velocity vectors, we are going to draw the velocity diagram. Now generally this is the one of the basic question every student will ask, sir, which method I need to apply? How I will be able to understand in this method, in this question I will apply velocity diagram method, or in this method I will apply angular velocity ratio theorem. How to understand which method I need to use? So my simple suggestion to everyone, guys, please focus here. My simple suggestion to everyone here is the questions in which mechanism will have two links which are parallel to each other, like this case. A mechanism in which two links are parallel to each other, in that case draw the velocity diagram, because in that case velocity diagram become very easy to draw, and you will get the answer in a single line. In single line you will get the answer. Okay, try to understand this point. So this is a case in which two links are parallel to each other. One more case I can draw here, like see. In this case also the links are parallel to each other. So whatever mechanism you have, need to understand, any two links should be parallel to each other, like this case and this case. Because why I am telling in this case use velocity diagram method, there is a reason. Because once you start drawing velocity diagram, it's very easy. Single line, straight line will be drawn, and you will get the answer in single line also. The diagram is also straight line and answer is also coming in a single line. Okay, only one step will be required. So please understand, okay, from this case, if this example, you can understand wherever the links are parallel to each other in any of the mechanism, I will use velocity diagram method. And apart from that, in all cases where the links are not parallel to each other, I will use angular velocity ratio theorem method. See why I am saying like that? Just because in such cases, the time required will be to solve this question will be very less if I use the velocity diagram method. That's what the main point we need to understand. Now please everyone solve this question and tell me your answers. Everyone try this problem. Okay, everyone should try and tell me your answer. Do it fast everyone and tell me your answers. Apply velocity diagram method, relative velocity concept you have to use, and draw the velocity diagram accordingly, and then tell me the answer for this particular problem. Do it fast everyone. So hardly you should not be taking like more than 2 minutes, but once I will discuss the solution, and after that you will not take that much time. Okay, but first you should solve this question on your own first. You should attempt this question first, then I will be discussing the solution. Why the velocity diagram method is more useful in this case. Okay, do it everyone fast. What is the first step in order to draw the velocity diagram? What is the first step? We need to draw the velocity vectors on the configuration diagram itself. Okay, let me just show you. See, this is the velocity, this is the configuration diagram, right? So in this configuration diagram only I will show the velocity vectors. So velocity vector of B with respect to A will be like this. Correct? Okay. Velocity vector of C with respect to B will be perpendicular to link, will be perpendicular to the link BC. Right? So perpendicular to it, it will have a direction perpendicular to link BC. Either upward or downward, we can we can assume also, but from the diagram actually we will understand where it will go. From the configuration diagram also it is very easy to understand where it is going. That this much visualization you can do, but actual understanding will be clear if you draw the velocity diagrams. So velocity of B with respect to A perpendicular to link AB, velocity vector of C point with respect to B will be perpendicular to link BC. Clear? Third, velocity of link C with respect to D will be perpendicular to link CD. Now the first step, what we need to do, first mention the fixed points. Fixed points are A comma D. A comma D are the fixed points. Generally in the small letters we are writing whenever we draw the velocity diagram. Okay, now see, A comma D is there. Now first of all, B with respect to A in horizontal direction. So let's suppose this is B with respect to A. This is the point B. Now velocity vector of C with respect to B is perpendicular to this line only. Okay, done. Now velocity of C with respect to D, D point is there. Okay, yes, this is point B I have mentioned, because in the question try to understand what they have given. Angular velocity of link AB is 0.2 radian per second. 0.2 it is given, and length is also given 50 centimeter. So I can easily calculate velocity of B with respect to A as AB multiplied by omega AB. Okay, so that's why I have mentioned the point B, because I know the location of point B, because when I will draw it graphically, I will place here because I know the magnitude of B with respect to A, because all the parameters are given in the question. So I can identify the location of point B. Velocity vector of B, velocity vector of C with respect to B. Velocity vector of C with respect to B will be perpendicular to link BC. So that I have drawn it here. So this is velocity of C with respect to B. Now velocity of C with respect to D is again perpendicular to CD, but actually it will be horizontal, in horizontal direction. So from D horizontal line we need to draw it. So let me just draw a horizontal line. Obviously it will coincide with the B with respect to A. It will coincide with the, okay, it will coincide with the B with respect to A. So this is velocity of C with respect to D. Now where both the lines are intersecting, at this point only, that point becomes C basically. So now you can easily understand, this is velocity vector of B with respect to A, velocity vector of C with respect to D. Both the values are going to be equal, as both the B and C coinciding. Okay, now see, this is what our velocity diagram. So velocity of B with respect to A equals to velocity of C with respect to D. Now B with respect to A. B with respect to A. So AB multiplied by omega AB, CD multiplied by omega CD. Right? So omega CD they are asking. Omega CD they are asking, right? Omega CD will be equals to AB by CD multiplied by omega AB. So AB length it is given as 50 centimeter, CD length it is given as 25 centimeter, multiplied by omega AB. Omega AB is given as 0.2. So 25 divided by, if I divide 50 by 25, 2 will be there, 2 multiplied by 0.2, you will get answer as 0.4. This is what the answer we are getting. I hope everyone this is clear, yes or no? So with this velocity diagram, this solution will take how much? With single step we'll get the answer, this much. So I've written the calculation part, but this is a single line answer, single line answer we are having, because single equation we have to use. So why I am telling, in such problems there is what we need to do, the velocity diagram approach we need to select. Why? In which problems of mechanism I need to use velocity diagram approach, and in which mechanism I need to use the angular velocity ratio approach. Simple point I am telling you. Again, please remember this point. The mechanism where two links are parallel to each other, a mechanism where two links are parallel to each other, there you have to use velocity diagram method. There you have to use velocity diagram method, right? Apart from the mechanism where two links are not parallel to each other, you should use angular velocity ratio theorem. Simple statement, please remember this thing, otherwise you will always confuse which method I have to use. You don't need to think anything extra, simple. Observe the mechanism, two links are parallel to each other, correct, I will draw velocity diagram and then I will solve it. But if the question have a like this, where two links are not parallel to each other, I will use angular velocity ratio theorem. Done? Okay. Going to the next part, guys. Flywheel question. Simple mechanism, everything we have discussed. Now the question from the flywheel, very important part. Very important question here, guys. Everyone should attempt this question. and such type of question you can expect also in your GATE examination. Everyone should attempt this question from the flywheel chapter. Entire mechanism we have covered, lot of concepts we have discussed from the simple mechanism. Now next concept is from simple mechanism. Okay, next thing we are going to discuss in the simple mechanism case. So take 2-3 minutes, but try everyone and tell me the answer, because already options are mentioned here, so you can mention the options, which option is correct here. Do it everyone fast. They are asking what the wheel mounted on a motor shaft to keep the speed fluctuation within plus minus 2% of the average speed. Okay, determine the moment of inertia. In the question they are asking the moment of inertia of the flywheel. This is one of the data given, and here most of the student will do mistake. That's why I have highlighted here also. Plus minus 2, which means from minus 2 plus 2, total value becomes 4%, not 2%. Okay, don't like confuse here. From minus 2 to plus 2, total variation is what? 4%, not 2%. So this is what important information. Everyone do it fast and tell me the answer. Do it everyone fast. I'm waiting for your answers. Okay. Now first you need to think like in which relation the mass moment of inertia will be coming. In which relation the mass moment of inertia is coming. See, lot of time students are asking, sir, they don't know how to start a problem. Simple thing, what they are asking, mass moment of inertia. You need to think about a relation where mass moment of inertia is there. In the flywheel chapter we have basically discussed so many formulas, so many relations are there. You have to think about all the formulas and see in which formula and relation the mass moment of inertia is present. Okay, you have understood that thing. Now think about the parameter relation in which this parameter is there. Formula or relation in which this parameter is there. First you have identified that formula relation, then think about the other parameters, whether they are given in the question or not. Whether other parameters are given or not in the question. If it is not given, is it possible to find those parameters? That also we have to think. In order to find those parameters, again which relation we need. So that's how we need to initiate in any numerical problem. Many students always ask, sir, how to start a problem. Simple thing, whatever unknown is there, that unknown will be somewhere related to any formula or relation. That we need to figure out first. Then we will start solving the problem. Like they have mentioned the mass moment of inertia. So there is one formula, delta E. If you remember, I omega square Cs. Very famous formula in the flywheel, and almost 80 to 90% problems are related from this formula itself. 80 to 90% numericals in flywheel are related with this formula only. Okay. So use this formula. Now you will be saying, sir, how to calculate delta E? For that they have given this turning moment diagram. CS value is 4%, I already told you, because total variation is 4%. So 4% means 0.04. So delta E value you will calculate from here. How to calculate? Delta E is the fluctuation in energy. First you need to find out the mean torque. So area above the mean torque level, whatever the area is there in turning moment diagram, above the mean torque level, that will be considered as a fluctuation of energy, maximum fluctuation of energy. Okay. Area above T mean. Delta E maximum. Maximum fluctuation of energy will be there. So whenever turning moment diagram is given, first identify the mean torque. So area above the mean torque level, whatever area we are having in the diagram, that will corresponds to what? Maximum fluctuation of energy. Once you have calculated, then this formula will give you the answer of mass moment of inertia. Okay. So first thing, the first step that we need to take here in this problem is to calculate the mean torque. And to calculate the mean torque, we need to know the relation. Total work done per cycle is what? Area under the T theta diagram. Total area under T theta diagrams give you the work done per cycle. Work done per cycle can also be written as T mean multiplied by the time period. See, work done per cycle equals to area under T theta diagram, which can also be written as mean torque multiplied by time period. This is the relation. Clear? So work done per cycle equals to area under T theta diagram, which is equals to mean torque multiplied by the time period. Right? So this is the relation. Now using this relation we will get the answer of the mean torque. So mean torque finally work done per cycle divided by time period. Okay. Work done per cycle is the area under the diagram. Area under the diagram we will be having this much area. Total area we have to calculate. Right. So first area is 200 multiplied by pi by 2. First part of the area. Then we have let's suppose we'll write this triangle. So 1600 multiplied by 3 pi by 4 minus pi by 2. Okay, so I am writing the area for, so which area I am writing? See everyone, this area will be equals to 1600 multiplied by 3 pi by 4 minus pi by 2. Correct? That is what I have written. Now next is this much area, triangle. In order to write this triangle, 1600 minus 200. Okay, again pi minus 3 pi by 4. Okay, the pen shifted to this side. Okay, no issue. Plus 1600 minus 200 multiplied by pi minus 3 pi by 4. Okay, then we have a small rectangle here, 200 multiplied by pi minus 3 pi by 4. Correct? Finally last triangle, 200 multiplied by 2 pi minus pi. 2 pi minus pi. So from this we will be getting an answer. Divide this, multiply all those things, okay, and add. This is the total area under T theta diagram, right? Divided by the time period. And see in the question, the duration of the cycle is 2 seconds. They have mentioned, divided by 2. So from here, mean torque answer you will be getting. everyone just do the calculation of this work done per cycle, which is nothing but area under T theta diagram divided by 2. You will get the answer of mean torque. Do it fast and tell me your answers. Do it fast everyone, the mean torque calculation here. Okay, time period, duration of the cycle 2 seconds, and total theta time period, basically angle here is 2 pi. See this question, see sometimes there are two types of things they will give. Turning moment expression they will give, T theta expression they will be giving, or sometimes they will give the diagram like this. In order to understand the time period, sometimes when diagram is given, the last angle after this again cycle is what repeating, that is what time period. So answer will be 2 pi time period. But once let's suppose torque expression is given in terms of theta, in that we have to find out the time period. How? Like what is the time period of sine, what is the time period of cos, what is the time period of tan. These things we need to know, basic trigonometry things, right? From that I can calculate the time period as well. So 2 pi here it will be, because after 2 pi you will have a cycle will again gets repeated. So time period after which the cycle will again get repeated is what, 2 pi. So that will be clear directly from the diagram. Directly from the diagram it will be clear, 2 pi. So just do this calculation everyone and tell me your answers. Okay. One more thing you can see, it's all about how you can calculate the area. How you will be calculating the area. So it's totally depends on us. So maybe you will write, sir, okay, this is 200. Entire rectangle I will calculate first. Then another rectangle. See, in 3 parts also we can do. This is another part. And let me write it, this one is separate. So this rectangle, green rectangle, red rectangle and blue triangle. Total 3 areas we need to calculate, sir. No need to write this much. So that's what we need to understand. Sometimes we are doing calculation, it will take more time, and sometimes we are doing calculation in such a way that it will take less time. So that's why I'm telling you this thing will happen, okay? And how you will get, like how you will improve when you will do more and more practice, okay? So this thing will not come suddenly, okay? It will take time. So when you are more involved in numerical practice, gradually you will understand which step will take how much time, and then accordingly you will select your steps also. Clear? So it's your choice. Final time period anyone has calculated? $462.5. 462.5 is basically the answer of mean torque. Once we have identified 462.5 as a mean torque, what we need to do? Now next, let me just remove all these areas, because now we will be focusing on the mean torque. So let's suppose somewhere here it is, mean torque. Okay, now see, area above the mean torque we have to take. This much area will belongs to the delta E max. This is what delta E. Delta E is the maximum fluctuation of energy, or the excess energy that flywheel is going to store. Are you able to understand? above mean torque, whatever area of work done is there, that energy will be stored in the flywheel. Clear? So that area we will calculate, because we have calculated mean torque value. This delta E we can easily calculate. Rectangle and triangle area we need to add. So delta E value we will be getting. Then that delta E value we have to use in this equation. Okay? Do it fast, everyone. And tell me your answer. Any answers, everyone? Tell me your answers. 462.5 is our mean torque value that we have calculated. And this delta E, fluctuation of energy, is the area above the mean torque. So this rectangle part and this triangle part we have to calculate. So this much length will be what? 1600 minus this mean torque. Correct? 1600 minus this mean torque value we have to put it here. Okay. So let me just write this delta E value also for you. 1600 minus mean torque 462.5. Okay. So 1600 minus this mean torque. So 16 minus mean torque is 462.5. And what is the difference? 3 pi by 4 minus pi by 2. Plus, next, this is what rectangle, next one is our triangle. Triangle base is what? Same. 3 pi by 4 minus, let me check, base is pi minus 3 pi by 4. Base is pi minus 3 pi by 4. Right, correct. The base is pi minus 3 pi by 4. So this one is what? Base, and this is what? Height. Height remains same, 16 minus mean torque. Right. So from here you will get the delta E answer. So now you can easily do the calculation and tell me your answers. Do it, everyone, fast. These are the very basic calculations, so I don't think so you will take so much time here. Should not be taking so much time here, guys. Don't do, okay, this calculation. I know calculation is there, but you have to be habitual in using the virtual calculator. You need to understand virtual calculator is like very important. If you are not habitual with the virtual calculator, definitely you are going to do some mistake in the examination. So please try to use virtual calculator on a daily basis. Become habitual with that. Sometimes everything you know that, but still if you are not comfortable with virtual calculator, you will be doing some mistakes. That should not happen, guys. Okay, so do the calculations, everyone. Do the calculation everyone first. Okay. Let me just write it here, the name here, because otherwise you will be confused here how to write the names. So let's suppose this is A and this is B, because here only the mostly mistakes will happen. This is A and this is B. Okay. Now what mistake usually we will do here, pi minus 3 pi minus 4 we will be writing. Instead of writing AB actual value, we will write this pi minus 3 pi by 4. So that should not happen. I hope you are getting the point. AB is not equals to pi minus 3 pi by 4. For that what we need to do, see, AB similar property triangle we need to use. Okay, we need to use similar property triangles. So AB divided by this distance, pi minus 3 pi by 4 equals to what? This distance 16 minus 200, that is we have complete 1600 minus T mean. 1600 minus T mean. Okay, let me write T mean here itself, no issue. Okay. Okay, we'll write it here separately, otherwise the page will turn automatically. See, AB divided by this distance, pi minus 3 pi by 4, right, equals to, understand this point, AB divided by this distance, next is what, total distance is what, this much, from this top point to this B point is 1600 minus T mean value divided by 1600 minus this 400, 1600 minus 200 basically, because here it is 200 mentioned. From here AB value we need to put, because see, calculation of the area if we have done wrong, then we will get wrong answers. So let me tell you again this thing. Okay, so by mistake what we will do, AB value we will be putting this much, so we will get wrong answer. Mean torque everyone got the answer, same answer, but see here the value will be coming here is AB. Let me just erase this part. Here AB will be coming. See, again see the triangle here. Okay, let me write this triangle AB and it is C. Let me write this is C. Okay. Now triangle ABC area we need to write. For triangle ABC area, half base into height. Base is what, AB, which is not pi minus 3 pi by 4. That's what the usually mistake we will do. Height is what, BC. BC is what, 1600 minus T mean. That is okay. Okay, that we have already mentioned here. Right. Now AB, how we have find out, using similar property triangle. So AB divided by this length, okay, equals to BC divided by this total length, which is 1600 minus 200. 1600 minus 200 total length. Got it? So this AB part, we'll write it separately again. 1600 minus 462.5 multiplied by, if you take the LCM, you will get pi by 4 plus half base into height. Base is what, AB, which we have calculated here, 1600 minus 462.5 multiplied by this pi minus 3 pi by 4, which is again pi by 4 only after taking LCM, divided by 1600 minus 200. This is AB distance multiplied by 1600 minus 462.5, like this. Finally, after solving this thing, you will get the delta E. Okay. So similar property triangle, this again, see, mathematics will be always be involved in all the engineering subjects. We do not forget basic mathematics actually. Got it? So from similar property triangles, we have written this thing. from similar triangle concept we have written that thing, AB value. So AB equals to 1600 minus bean torque multiplied by pi by 4 divided by 1600 minus 200. So now I hope you have solved this delta E value. Now delta E value, I already solved this thing, so delta value is coming around 1256.3. It is coming around 1256.3 joule. Approximately this answer is coming. Now delta E formula that I have initially told you is what? I omega square CS, omega average basically. This relation we need to use to calculate the mass moment of inertia value. Use this relation to calculate mass moment of inertia value. Do the calculation, guys, everyone fast. In the question they have given the RPM, okay. The motor driving the machine has a speed of 1500 RPM, okay. So 1500 RPM they have given, that we have to use here. If RPM is given, so how you will calculate omega? Omega is 2 pi n by 60. That is the formula of omega here that we will be using here, okay. Putting all those values, you will get the answer of mass moment of inertia, everyone. Do it, everyone, fast. Answer approximately, if you solve, it will coming around 1.27. 1.27 it will be coming finally. Kg meter square. This is what the final answer. So this is, I know, little bit lengthy problem, okay, but we have to be very careful regarding the calculation part. Regarding the calculation part, we have to be very careful. Like I've told you now, like how mistakes will be done. That's I've mentioned here already. Instead of AB, I put this thing, which is wrong actually. So because these things will happen when we are in so much hurry to solve the question, right? You know these things. So that's why whenever a numerical problem is there, we have to be very calm, okay, calm and composed we have to maintain, so that whenever we are solving question, doing calculation, we should not do anything small silly mistakes. Like this is only silly mistake. Instead of taking AB, we have taken like this directly. That's what wrong, okay. So this is ABC, let's suppose this point is D and this point is E. So from similar property triangle, what actually you will be writing? Let me write it here itself. You are actually written AB divided by this base DE equals to, you have written BC divided by DC. This is what you have used from similar property triangle. AB divided by DE equals to BC divided by this DC. Got it? Now flywheel done, everyone, and I'm telling you everyone, guys, this delta E formula equals to I omega square CS. This is a very important formula, and most of the questions you will see from this formula only. This one and next another one, like work done per cycle, which is like one of the formula is area under T theta diagram, right? Another formula is what? Integration T d theta. Integration will be from 0 to time period. Okay, I've told you how to find out the time period. If the diagram is given like this case, so the point where the cycle is stop here, again the cycle will repeat. So 2 pi is the time period, not the 2 seconds. Don't be confused with that thing. Okay, 2 pi is the actual time period, the time period after which cycle again repeats, right? That is given. Okay, so this is one formula, another formula, third formula also. Let me write it here itself for you. Mean torque multiplied by the time period. These are the three formulas that you need to know to calculate work done per cycle. These are the three basic formulas. Is it clear? Three basic formulas that you need to understand for calculation of work done per cycle. And okay, one more relation. Okay, delta T will be equals to I alpha. Alpha is what? Angular acceleration. Delta T, if mean this T actual is more than the mean torque, you will have angular acceleration. If your mean torque is more than the actual torque, so you will have a retardation. Or in order to calculate maximum alpha, you need to use here T max, maximum torque minus mean torque, equals to I alpha. So I alpha, that mass moment of inertia alpha value will be automatically maximum here, because we have used, okay, because we have used what? Because we have used maximum torque here, right? Is that clear, everyone? Okay. Now next, this question is for homework, guys. This question I will keep it as homework. Next session that we will have tomorrow, I will ask you whether you have done this one or not. Okay. You can take the question, you can solve this question after ending of this session, but whatever information is given in the question here, please try to understand carefully and then try to solve. Just little bit information I will tell you here regarding what they are actually asking. See, first of all, they have given up, it is a flywheel which is used in punching case, right? Okay, diameter 4 centimeter, holes 3.1 centimeter thick plate, 65 okay kg meter of work square meter centimeter shredded area. So actually shredded area they have given. See, 65 kg meter of work per square centimeter of the shredded area. The punch has a stroke of 10.6 and punches 8 holes per minute. Maximum speed of flywheel at its radius of gyration is 29.5 meter per second. Got it? So this all information is given and they are asking weight of the flywheel. So this question is homework for you guys. Try to solve it. Tomorrow we'll discuss the solution. Now coming to the next topic. Now we will be discussing the gate train, guys. Gate train, again very important topic for the theory of machine subject. Okay, theory of machine subject, today's gate train will be the last topic, and after that tomorrow session, which is at 5 p.m. we will discuss flywheel already covered. Gate trains, one numerical we will be discussing now, but after that vibration. Everyone knows how much important part is vibration. Always 2 to 3 numericals, at least 1 or 2 numericals are coming every year, you can check. So vibration very important. Gyroscope we will discuss, balancing we will be discussing, and some part of the cam and follower also. So tomorrow session is also very important. Tomorrow at 5 p.m. we will conduct the session, right? Now everyone try to understand. Before solving the question here, we should know some basics. What is the basic part? See, there are 2 gears. Okay, simple, you know that this is what the meshing. 2 gears are under meshing condition. But this is what actually we call it as a line diagram. This is what you will see in the books. This is the 3D diagram we have. Okay, this is the diagram we will see in the books, and this is what we call it as a line diagram. Okay, this is what we have as line diagram. Clear? Is it clear, everyone? Tell me. Okay. Now another case, please try to understand, because there was a one question asked in gate examination related to the line diagram. Related to the line diagram there was a one question, and most of the people assume that it is a tough. No, not at all. It is not a tough question. Only thing is that you have not completely understood how to draw the line diagram for gate trains. So today we will discuss that concept also. Okay, see, this is the internal gear. For internal gear, how we will draw the line diagram? See, the teeth will be cut inside. This is the representation of internal gear in terms of line diagram. External gear you will see like this, internal gear like this. So this is the line diagram. Okay, line diagram for the internal gear. Now see everyone, carefully understand. This is a case of internal gear and there is an external gear. How we will represent in the case of line diagram? See, this is what we have a external gear, right? This external gear is under meshing with this internal gear. So whenever these two lines are in parallel, you will understand what meshing is happening here. This is what meshing. This is what meshing we are having. Is it clear? Done? Okay. Now one more case, epicyclic gear train. How to draw the line diagram of epicyclic gear train, or if directly line diagram is given, how we can understand what actually they have mentioned. Okay. So what happens? No, they will directly give the line diagram. First you need to understand this as an epicyclic gear train. Okay, this is the arm we are having, this is one gear and this is another gear. As already know, everyone knows that in epicyclic gear train what happens, gear is rotating on its own axis and also with respect to another gear axis. Like this gear I am talking about, this gear is rotating about its own axis as well as about this axis also with the help of arm. Now how the line diagram we will draw? Generally in epicyclic gear train, generally what we will do, from the bigger gear, that is we are having this bigger gear, there is what center. Okay, from this center we will draw one line, because actually half part of epicyclic gear train we are showing. So this dotted line represents what? The shaft axis of this bigger gear. Now first of all, this is what external gear. See, this is external gear. Now this external gear is connected with this gear through arm. So this is what we have as arm, because this external gear is connected with the bigger gear through this arm. What about this one? This is what the bigger gear, but it is drawn on a half basis. That's why you see, okay sir, it is small. Why it is small? Because it is half drawn. This gear is what this gear, actual size we have drawn here, but for this gear, okay, we have taken the half. That's why this gear, if you see, it is bent like this. The gear which is drawn half, it will be bent always like this. Don't be confused with the case of internal gear. In internal gear, we will draw inside the teeth. Teeth are external only, okay, not inside. So don't be confused regarding the internal gears. Okay, done. Now one more case we will discuss here. Okay, now after that we will directly jump to the problem. Directly we can jump to the problem here. Okay, now see everyone, carefully understand. This was the epicyclic gear train again. Now this is what we call as a line diagram. First of all, this bigger gear is our internal gear. Internal gear. This is our internal gear. See, you can understand how the teeth are drawn towards inside size. Towards inside the teeth are drawn, right? So this is representation of internal gear. Okay. Now these two parallel lines, whenever you observe, it is what? Meshing. Meshing of which gear? This internal gear with this gear. Okay, so that is what we have drawn. For this gear we have drawn like this. Another meshing, this gear and this gear meshing is there. Okay, another meshing is there, and this is what we call as arm. arm is connecting which gear? This gear with the center of the main. Okay, main central axis is this one. So this gear has been connected with this main central axis with the help of arm. That is what we have shown like this. And this is what internal gear is drawn on a half basis. Internal gear has been drawn on a half basis. Similarly, this center gear also drawn on a half basis. You will see it is bent like this. Internal gear is also bent like this. So this is the basically the way of representing the gear trains in line diagram. Clear? Okay, now we'll jump to the problem directly. And this was the question asked in GATE 2010. Okay, in 2010 they have asked this problem. Very important question, guys. Only for the first time only they have asked this question. Okay, after that it has never been repeated. It has not been again repeated, I'm telling you. So again chances are there, because this question is important. Why? Because mostly student will confuse in the understanding of the gate train only. If the gate train is given like this, then it is okay. But if it is given like this, most of the people will not be able to understand the gate train. So that's why the problem will be there. But we have discussed how the line diagrams are drawn. So there is not any problem here. Just from the line diagram only I will understand which gears are under meshing, which is internal gear, which is external gears. All the things will be able to understand. Okay. See how we will solve this question. First of all, if you observe here, see in the question itself they have mentioned the arm. Arm is connecting, okay, arm is connecting a shaft, the shaft which connects the gear 3. This is gear 3 and this is gear 4. Gear 3 and gear 4 are connected on the same shaft. Gear 3 and gear 4 are on the same shaft, and that what connected through the central axis with the arm. I hope you are able to understand. Gear 3 and gear 4 are connected on the same shaft, which means omega 3 equals to omega 4. This is the first information that you should understand from the given gear train. Got it? Omega 3 equals to omega 4. Next, gear 2 and 3 have a direct meshing. 2 and 3 is having direct meshing and 5 and 4 having direct meshing. But gear 5 is your internal gear. Okay, gear 5 is your internal gear. Gear 5 is your internal gear. Is it clear, everyone? Okay. Now, gear 5 is an internal gear meshing with gear 4. Gear 3 is meshing with gear 2. According to relative velocity method in the gate train, we can solve this question with simple 2 steps. Okay, we'll not use conventional method of drawing a complete table here. Okay, that tabular method we are not going to use because it is more time consuming. We have to solve question in a minimum possible time, so we'll be using a simple relative velocity method. Okay, hardly 2 steps will be required. Once we have understood how the gears are meshing with respect to each other, everything we have discussed, now I can directly apply our method here. See, gear 2 and 3 are under meshing. Simply omega 2 divided by omega 3. They are in direct meshing. So what I will write, omega 2 with respect to arm, omega 3 with respect to arm. So in relative velocity, we are writing velocity with respect to arm always. With respect to arm, we are writing the velocities. Okay, let me change the color because it is too light. Okay, let me use red color. Omega 2 with respect to arm divided by omega 3 with respect to arm. So what happens here? See, understand everyone. So what we will be writing here? Omega 2 minus omega arm. Okay, that will write later, but before that we'll write T3 by T2. Now it is a case of external meshing, so negative sign will be coming. Correct? Okay. Second thing we can write, between direct meshing happening between 4 and 5, but internal meshing. Okay. So omega 4 with respect to arm divided by omega 5 with respect to arm. So T5 by T4, but positive sign because of internal meshing between gear 4 and 5. Between gear and 4 and 5, internal meshing, so positive sign because sense of rotation will remain same. Got it? Okay. So omega 4 with respect to arm, omega 5 with respect to arm, 2 with respect to arm, 3 with respect to arm. This is equation 1. This is equation 2. Now let's suppose if I multiply both the equations, as everyone knows that 3 and 4 are on the same shaft, they will have same speed. Once I will multiply equation 1 and 2, denominator in the equation 1 and numerator in the equation 1 are equal. Yes or no? In the denominator of equation 1 here, omega 3 with respect to arm, and numerator of equation number 2, that is 4 with respect to arm, both are equal because gear 3 and gear 4 are on the same shaft. So speed of rotation will also be same. Okay. So once you will multiply, you will have only omega 2 with respect to arm divided by omega 5 with respect to arm. Right? Got it? And this minus sign will be there, T3 by T2, T5 by T4. Okay, so this is the equation that we will be using here to solve. So let me write it here, omega 2 minus omega arm, omega 5 minus T2 multiplied by T4, like this. Clear? Okay. Now all the values are given. Omega of arm 80 radian per second counterclockwise. So it's our choice. Counterclockwise, positive or negative, it's our choice. Okay. Whichever way you are using, you will get same answer. But you have to remember what notation you have assumed. Omega 2 given as 100. Okay. Omega 5 they are asking. Okay. Omega 2 is 100 clockwise. Omega arm 80 counterclockwise. So minus 80 I will write. Because counterclockwise I am taking negative. Okay, equal to, not multiplied sign. And what about the angles? Number of teeth basically. T3 value they have given as 24. Minus sign is also there. 24. T5 value is 80 divided by T2 and T4. T2 is 20, T4 is 32. From here omega 5 is just a matter of calculation for you. Just a matter of calculation for you guys. Okay. Do it fast and tell me your answers. Now it becomes very easy. So you can easily tell me your answers. Minus 140 RPM. Minus whenever we will be getting here. So what I will say? Minus sign simply denotes counterclockwise. Counterclockwise. And if you see option, clockwise and counterclockwise both mentioned. So option C is the correct answer. So again I am telling you guys, here the line diagram is very important. Other than all the questions are very easy. Once you have understood the concept of line diagram, then all the problems of epicyclic given in line diagram will become very, very easy for you. Got it? So this line diagram you need to understand how the internal gears will be mentioning, okay, how internal gear they will define in the line diagram and how external gear they will define in the line diagram. Clear? Okay guys, so that's all for today's session. In the next session, that is on tomorrow at 5 p.m, we'll be discussing the vibration, most important topic for entire theory of machine. Okay, we will discuss gyroscope topic as well and balancing topic and some part of the cam. So attend tomorrow's sessions also. Okay, and by attending tomorrow's sessions, your entire theory of machine numerical practice will be done. And after that, only you need to revise your formula sheets and just few PYQ questions you need to solve again, so that approach will be clear to you. Okay, so please share this session with your friends. Okay, so they will also get benefited from this sessions. Okay, thank you so much everyone. We'll meet you tomorrow at 5 p.m. Thank you.